All right, today we're going to talk about vertical and horizontal shifting. So I've been saying this all along during class. So basically what we're saying is we have shifting that can occur vertically, which is up and down. And that's why we call that the yes kid, because when you nod your head, it's up and down. And we have horizontal shifting, which we call the horrible kid. And the reason why we call it the horrible kid is because horrible sounds like horizontal. So hopefully you remember. So this is just some stupid things that over the years my classes have come up with. So the good kid does exactly what mama says. Therefore, a vertical shift is always on the outside of a parentheses. Notice right here, here's my parentheses, but the shift is on the outside. And we came up with a stupid saying for that too, is that if you're the good kid, you get to go outside and play. You're not grounded. The horizontal kid, the horrible child, gets grounded. So therefore, anytime we're shifting something horizontally, it's because the shift is occurring inside the parentheses. And the reason why he's grounded is because he's done exactly the opposite of what mama says. So he has to stay inside. He has to stay in the parentheses and be grounded. So it's really simple to do. Let's say we have this function, f of x, which is over here. All right, I just made a copy of it. And we want to create a new function that we're going to call g of x. And g of x said that we're going to take function f and do some shifting to it. And the shifting we're going to do is one horizontal shift and one vertical shift. Now, we have to follow order of operations. So the first thing we would like to do is you're going to shift horizontally, because the first thing that happened to the x was it got -3. So I'm just going to say, okay, I'm going to pick the points that are easiest. And there I am. I just picked basically the bents of the graph. And the first thing they said was x -3. Well, guess what? That's an inside shift. So that's horizontal. Horrible. He did the opposite of what mommy said. Mommy said do -3. So I'm going to go +3. So every point on the graph moves 3 places. And you can see now why it's easy to just move the bent parts or the concavity changes. And the last thing mommy said was go +2. Now the +2 is on the outside. Outside are the good kids. Good kids get to go outside and play. So now everybody has to go up +2. And what you should see is you get the exact same shape, just shifted. There you have it. That's how easy it is to do. And it works for lines as well as it does for parabolas. So let's say I have mama function of x squared, and we know that 0, 0 is her vertex. And then we're going to do our over 1, up 1, because her a value is 1, so her stretch is 1. Over 1, up 3 times 1. Over 1, up 5. There we have f of x. Now, I would like to create a new function, g of x. And once again, I don't really have to worry about this squared. This is telling me that every x value, we're going to -1. Oh, so wait a second. That means I'm the horrible horizontal kid. I'm inside parentheses. -1 means I'm going to +1. And then I'm going to -3. So basically what I'm going to do here is I'm going to turn it blue. And the joy of my notebook means I can just apply. -1 means every point moves +1. -3 is on the outside. So that means I get to go outside and I obey exactly what Mama said. So I'm just going to take every point and move every point down 3, and there you go. Now, this being a parabola, hopefully you would have done the shortcut. And the shortcut, if I use my yellow, would have said, oh, I know that my vertex is 1, -3. And there is 1, -3. And then I can apply my steps. Over 1, up 1. Over 1, up 1, 2, 3. You get the idea. Over 1, up 1, 2, 3, 4, 5. So there was plenty of different ways to get the baby blue function. That's it. Pretty simple. See you tomorrow.